Welcome back to our series on cracking the coding interview. Today we're going to be solving a problem called return kth to the last. Okay, this is a problem we've solved before, but today we're going to use a different approach to solve this problem. And also today we're going to take this into consideration. This says if you can imagine two pointers pointing to adjacent nodes and they were moving at the same speed through the list, can we solve it this way? So feel free to pause the video just to read through what this problem is asking for, but find the examples more descriptive. Suppose we were given a linked list, for instance, like the one in this example right here. Suppose this was the linked list we were given, and we're asked to find the kth to the last element, where k was equal to, okay, k is the value of 2. So let's say k equals 2. So meaning we want to find the second to the last element, which in this case is going to be 6. Okay, how would we go about this? The first thing I'd like to do to solve this is to create a pointer. My first pointer, I'm going to call him fast. Again, keep in mind that I'm creating two pointers, but both pointers are going to move at the same speed. But I call this fast because he starts before the second pointer. Okay, feel free to call him first instead of start first and second for both, rather than fast and slow, because that might be a better name. But I'm going to call him fast. So he starts first, and we're going to move him up to the k element, the kth element. So since k equals 2 in this example, we're going to move him up to the second element. Keep in mind, not the second index, okay, because linked lists typically don't use the concept of indices. I just like to write the indices above them, so it makes it easier to explain it. We're going to move him to the kth element, which is the second, right? We're going to move fast from the head node to the kth element, which in this case happens to be the second element because k equals 2. So fast is going to go right here. Then once we have fast, we're going to create a second pointer, who I'm going to call slow. From this point on, fast and slow, these two pointers are going to move at the exact same speed through this list. So for instance, in the first iteration, slow is going to be at index 0. So slow is at the head index, which is index 0, while fast is at the second element, which happens to be index 1. So in this case, what do? Every time we do this, we're just going to move fast and slow at every iteration. So what we're going to say is slow and fast are both equal to slow dot next. So slow equals slow dot next, and fast equals fast dot next. So essentially what we just did is just move both of them. Okay, so let's move fast equals fast dot next, so fast is here now. Let's also move slow equals slow dot next, so slow also happens to be here now. That's how the first iteration. Second iteration, slow now is at index 1 and fast is at index 2. So again, we do the exact same thing we did in the previous iteration, which says slow equals slow dot next and fast equals fast dot next. Essentially what this does is move our fast pointer to the next guy and move our slow pointer to his next guy. Again, I wouldn't bore you with this, but again, we're going to repeat this through every iteration till fast gets to the last element. So it's going to look something like this. We're going to keep doing this. I'm just not going to write it out. The last element, fast, is going to be right here. And guess what? Slow is going to be right next to him, right? It's going to be adjacent to him. And the idea is that once fast gets to the last element in the list, slow would always be at the kth to the last element, because keep in mind, we initially started fast off kth element away from slow. So if k was 3, whenever fast got to the last element, slow was going to be somewhere here. K was 4, slow was going to be here, and on and on. So without further ado, let's go ahead and put the solution to code and see what the code looks like. So the code is actually fairly simple, to be honest. So I've gone ahead and created the node class, which is the building block of our linked list, of any linked list in general. Okay, let me go ahead and make this full screen. Then I've created the linked list where the first node is node of 0. Okay, just like our example. Then I've created the append function to add to our linked list and the display function so we can see or visualize our linked list. And now this is the function we're going to be adding in. So I've gone ahead and created a linked list of even numbers from 0 to 8, to 10 technically, but with 10 not inclusive because the range operator is exclusive of the upper bound. I use the for loop to create that, and I'm displaying the list here, and then I'm calling my function here saying give me the second to the last element. But again, we haven't edited him. We're going to do that now. This is, like I said earlier, this is a very simple code, to be honest. So let's first start with our fast pointer. I'm going to set him equal to self dot head. Okay, we set him to the first node. Now let's move him k times, right? Okay, so we're going to do 4. We don't need this index, so we use the underscore whenever we don't need the index. So we want to move in k times technically, right? In this case, we're gonna say if fast, as long as fast is defined, as long as fast is not none, right? It's gonna be equal to fast dot next. So now we're done with fast, okay? Oh, actually, we're not yet done. Let's have an else statement. Okay, in else case, else meaning fast is not defined. We're just gonna return none, because obviously we have nothing to return, right? So at the end of this loop, at the end of this for loop, we're gonna initialize our slow. So slow is now gonna start. So now slow has started. So at this point, keep in mind that fast pointer is k nodes away from slow pointer, however many k is. But now let's move slow. So while fast, as long as fast is not none, he hasn't gone into the none. So let's move fast and slow. So fast is gonna be equal to fast dot next. The same thing for slow. Slow is also gonna be equal to slow dot next. And then in the end of this while loop, we're gonna return slow dot val. So let's go ahead and run this and see what it does for us. You can see it returns 6, the second to the last element. Let's get the last element, 8. Good. Let's get the third to the last element, which should be 4 in this case. Let's get the fourth to the last, which should be 2. Okay, 2. Bam. Let's extend this to print even numbers from 0 to 20. Okay. So from 0 to 20, the fourth to the last is, this is the last, first to the last, second to the last, third to the last, fourth to the last is 12. So that's it. We can see this code works. That's it for this video. I hope it was helpful, and I'll see you in the next one.